Okay, so the previous day we talked about how to solve radical equations, right? Well, today we're going to be talking about, dun, 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 how do you solve square root inequalities? Okay, you're like, how would we even do this? Okay, I think the big thing is you get to solve it, and you also have to keep in mind the domain of the problem and see where those two coincide. Okay, so let me show you kind of a quick glance as to what this would look like. So I think the first thing is, hey, let's find the domain. Okay, what do you mean? Well, what are you allowed to square root? Well, you're only allowed to square root things that are greater than or equal to 0. So what we'll start with is finding that domain. So we're going to just take what's underneath the radical and haul it over here to find the domain. Okay, because the thing is, it's no good to be like, oh, I found some answers. You're like, yeah, but they're not actually valid. Like, they're not even real. So we don't want to go imaginary while we're trying to find these solutions, because that's just kind of beside the point. So we want to keep things real and define the solution. So keep it real. So we take what's underneath the square root and we say, let's find the domain. So 3x minus 6 has to be greater than or equal to 0. So no matter what, you can't take the square roots of negatives. We're not going to go imaginary while we're solving the problem. So if you plus 6 to both sides and then divide by 3, okay, you're going to get x has to be, no matter what, okay, no matter what you find for an answer, x has to be greater than or equal to 2. Okay, so that's the domain. Okay, so you may find an answer like, this is the solution to all the problems. You're like, keep it real while you do it. Okay, and so we have to find out where those coincide. Okay, the other thing to do is we're going to just solve this like a big kid. So if you minus 4 from both sides, okay, find the solution, see what works. Okay, and then we'll try to keep it real. And that combination of things is going to be our final solution. So we're going to square both sides. You get 3x minus 6. Again, when you are solving and you're squaring both sides, sometimes you introduce extraneous solutions. So that's, again, why we're trying to keep it real. Okay, so here we go. Add 6 to both sides, you get 3x. Be less than or equal to 15. Divide by 3, you get x is less than or equal to 5. So let's see. Some people can see what's going on here. We're like, oh, yeah, it's not, if you got to obey both these rules and figure out where they overlap, I can tell what it is. Okay, there are lots of ways you can do test points. You can kind of look at the graph. Okay, the first graph, the answer that says, hey, all it has to do is be less than or equal to 5. Okay, so here's 5, less than or equal to 5. They're like, yeah, those answers will work. You're like, yeah, but can we keep things real while we're doing it? It may be accurate, but like if it goes imaginary at the same time, it's not so good. Okay, so this one says the domain is x is greater than or equal to 2. Okay, so it has to be greater than or equal to 2. Can you tell where the region is that works for both? You know, where both the shading and the double shading is? Can you tell that it's actually in this section right here from 2 up to 5? Okay, so if it obeys both rules, where are the values that obey, that are true, that will work, but also stay real? Okay, you know, think about this. If you tried 0 and plugged it in here, 3 times 0 is 0 minus 6 square rooted is a negative number that we're square rooting, and then plus 4, is that less than 7? It's imaginary. How do you even quantify that? Okay, so the thing is, the overlapping values that are real and true are going to be between 2 and 5. Sometimes it's between things, sometimes it's to the left of stuff, sometimes it's to the right of stuff. So there's 3 different options. Okay, this is between those 2 numbers. And if you want to just try a test, I'm like, let's try 4, see if it works there. Does it actually keep it true and actually stay real? You know, so if you try 4, 3 times 4 is 12, minus 6 is 6. The square root of 6 is a number like 1-ish, you know, 2-ish. And then plus 4, yeah, that is smaller than 7. Okay, so that actually works. So between 2 and 5 would be good. So 2 all the way up to and including 5. Notice they're filled in. Okay, so that's going to be your solution. Isn't that cute? On this one, again, let's find the domain. You take what's underneath the radical to find the domain, and you say 2x plus 2 has to be greater than or equal to 0. And you minus 2 from both sides, divide by 2, and you get x has to be greater than or equal to negative 1. Okay, so your domain says, hey, let's keep it greater than or equal to negative 1. If it's, you know, open circle, that would be an option, but this says greater than or equal to 1, negative 1. Okay, and then let's find the solutions that make it true. Okay, so you just solve it and be like, okay, and then let's see, how do we make it true and keep it real? So you minus 1 from both sides, you get square root of 2x plus 2, well, that's an x, plus 2 is equal to 4, greater than or equal to lies. And then we've got, let's see, square both sides, you get 2x plus 2 is greater than or equal to 16, minus 2 from both sides and divide by 2. You get x is greater than or equal to 14 divided by 2 is 7. Okay, so greater than or equal to 7. So 7 is here. Okay. Can you tell where the graph is double shaded? Okay. 0 wouldn't work, -5 wouldn't work, 1 wouldn't work. Basically, from 7 to infinity is where it will stay real, but also be good. So from 7 to infinity, okay? And you could try it. Be like, oh, guess what? Those answers will actually work. You can try 8 or 9. You might need a calc to evaluate it, but those would be the values that keep it true. All right, let's check the last one. Okay, again, we're trying to keep things real. So take what's underneath the square root and be like, okay, 4x minus 4. You always do greater than or equal to 0, no matter what you got. So add 4 and divide by 4. You're going to get x is going to be greater than or equal to 1. Okay, that's your domain. I like to graph it. You don't have to. Okay, greater than or equal to 1. Okay, if you solve it to find the answer, you plus 2, you get 6. And then the square root of 4x minus 4, square both sides, you get 4x minus 4 is going to be less than 36. Add 4, you get 40. Divide by 4, you get x is going to be less than, it appears to be 10. Okay, so I'm going to get another color. X is less than 10. Okay, notice this is just an open circle at 10. Okay, where is it double shaded? Okay, where is it double shaded? It's going to be double shaded between here up to, but not including 10. Okay, so between 1 and 10 will be your solutions. And if you try any point from 1 up to 10, but not including 10, you will get values that are true, but also will not take the square roots of negatives. Like try 3. 4 times 3 is 12 minus 4 is going to be 12 minus 4 is going to give us 8. Okay, and then square root of 8 is a positive number, like 2-ish, okay? Minus 2 is going to be smaller than 4, okay? Actually, it's 3-ish. Well, you can do the math and figure out what that is, but plug it in there and make sure not only it's a positive square root, but you're going to do it. So no, I'll do it again. So let's do that together. So do 4 times 3 is 12, minus 4, and that's 8, the square root of 8, and then minus 2. Hey, guess what? That's 0.8. Yes, that's smaller than 4. Okay, so anything you try in that region would only be true, but also real. All right, thanks. Have a